All right, so good morning. All right, GM to you, Auryn from Interfold. How you doing?
Yeah, I'm doing well, thanks. Thanks for having me.
All right, that's great. That's great. So this is going to be our first interview, right? So I would love you to please introduce yourself to us and tell us what you do. Just tell us a brief history about yourself. That's what we'd like to know.
Yeah, for sure. So hey everyone, I'm Auryn, founder of Notice Guild and the Interfold. I've been floating around the Web3 space, or I guess the blockchain space, since 2013 and kind of worked in a variety of different roles with a variety of different organizations, but I guess, most notably here, I've founded Notice Guild, and we've been working on this project called the Interfold. It is, I guess the original inspiration for this was actually MACI, the Minimal Anti-Collusion Infrastructure, which was an idea proposed by Vitalik a number of years ago, and that, was essentially private voting as a zero-knowledge circuit. And we had been playing around with this in a variety of different contexts for a while, frustrated with the centralized coordinator assumption that it had, and so wanted to try to figure out how do we distribute trust in that coordinator. And this led us to this architecture that ultimately grew into the Interfold. And I think the real kind of light bulb moment for us was realizing that voting was just one of a whole kind of handful of, or a whole ecosystem of use cases that could benefit from this style of compute, essentially being able to take many private inputs, arbitrarily compute over them, and then produce a verifiable output.
Oh, that's awesome, right? Yeah, that's actually very good. It's interesting. I think so far I've read a lot about Interfold, and I'm like, wow, like having three different privacy stacks together, ZK, FHE, and I think decentralized threshold technology as well. It's massive actually. So now I think let's start at the beginning, right? So now I figured the Interfold traces its roots back to Gnosis Guide. So do you mind telling us the origin and then the core problem we're trying to solve, right? What exactly made you realize that? What made you realize that existing infrastructure wasn't enough and you needed something like the Interfold? Yeah.
Yeah, so this goes back to what I was just saying with MACI, right? We had been using MACI in a variety of contexts. In particular, had been playing with it in the context of ClearFund, which is quadratic voting built on top of MACI. And MACI is voting as a zero-knowledge circuit. And I guess one of the nuances that's not necessarily widely appreciated with zero knowledge is that someone has to know the data that you ultimately want to prove something about.
Yeah.
It's great for proving things about data that you own. You know, if you need to prove that you are older than some age without revealing your actual age, or that you live within some region without revealing your precise address or something like this, then it works great because you know that data and you can prove things about it. But when you have multi-party systems where you want to prove things about the private states of many different people without them revealing those states to one another, then you get into this tricky problem with ZK alone. And so this is the reason for this mashup of different cryptographic technologies, essentially to enable us to prove things about the aggregation of private data without revealing that private data to any individual third parties. And so we use ZK, zero knowledge proofs, for verifiability, essentially to allow us to say that this output that we're claiming is verifiably the result of the inputs that were provided by a whole bunch of different independent parties, using fully homomorphic encryption to allow us to compute over the private state that's encrypted from, again, a variety of different independent parties, and then threshold cryptography, or MPC, to allow us to distribute trust in the decryption authority for that output that's provided by the verifiable computation.
Yeah. All right. So that was that was a bit long, right? And I think one thing I've noticed honestly is that many people actually do see privacy as a niche, right? They see it as a feature, and personally, I believe it spans way beyond just a niche. It's not exactly a niche. I think it is the infrastructure that was supposed to be there from the onset, right? And for persons that are starting, that are more like new to the whole privacy infrastructure, like why should they exactly care about what the Intervolt is building, right? Like how does Intervolt exactly fit into the broader landscape of encryption privacy and a lot of other stuff. Yeah.
Yeah, so I think there exists a class of application that they either were not possible or made really significant trade-offs in how they handle data or what they enable because there was not, because this essentially stack of technologies were not yet mature, right?
Yeah.
So the kind of de facto alternative for something like the Interfold currently is trusted execution environments. These are hardware-based security guarantees. People use them for both guarantees around correct execution as well as guarantees around privacy. You can kind of decouple these and use them in different combinations, but ultimately the guarantees that you get from a hardware-based solution are always going to fall back to a manufacturer and supply chain based attestation. So essentially attesting that the thing was built as intended and the custody chain has been kind of respected. Someone with physical access to the device and some specific know-how is able to compromise it in a variety of different ways. And I think we've seen a significant number and kind of ongoing string of different vulnerabilities exposed in trusted execution environments that have essentially just made them untenable for a lot of really high value use cases. And again, given that they are then, the custody is always in an individual or a kind of firm's control for large decentralized systems, again, it's a kind of untenable trade-off in a lot of cases. So I think that, yeah, the fact that that's been the de facto, I think, has held back or at least like stopped a lot of potential use cases from exploring or being able to leverage kind of legitimately private technologies there and then ultimately making other trade-offs. And I think a good example of this in terms of other trade-offs is governance in the Web3 space more broadly. It has tended towards fully open, fully public voting for the sake of verifiability, right? So that you can see that you can guarantee that the outcome is the result of the votes cast by constituents in a given organization. And yeah, this ultimately leads to kind of suboptimal outcomes, right? Transparent voting gives us this opportunity to coerce, collude, bribe, or otherwise kind of manipulate outcomes in a voting system. And so while what we kind of gain through verifiability, we end up losing to coercion and collusion. And so, yeah, I think having this stack of technologies maturing now simultaneously to enable us to build systems like the Interfold really gives an interesting new option for organizations and applications to make a fundamentally different set of trade-offs in how they design their systems and ultimately have a fundamentally different set of guarantees.
That's actually interesting for real. Like, because the fact that that's, I think, naturally leads to how the technology actually works, because a lot of people hear this concept and sometimes they assume that it's just extremely complex, right? So now, the Interfold introduces a concept called the E3. Now, I would like to understand what, or rather we, because I know I'm not speaking for myself, right? I'm speaking for everyone that are watching this later. So, what exactly is the concept of the E3 exactly? And if I were a user or rather a developer interacting with Interfold today, what would actually be happening behind the scenes from the start to finish? So, I don't know if you can, yeah.
Yeah, absolutely. So E3 is a kind of acronym for encrypted execution environment. I would love to make it E4 and add ephemeral on top of that, ephemeral encrypted execution environment. But it doesn't roll off the tongue quite as nicely. So basically the idea here is that you have a variety of different components and actors that coordinate to produce something that, when you interact with it, is essentially this kind of virtual execution environment. So you have an on-chain entry point where you would request a compute job happens. That's going to trigger a sortition process to select a group of node operators from our pool of available node operators. Those selected node operators then coordinate to do this distributed key generation ceremony, produce a shared public key that is whatever party size and threshold size you've requested, publish that public key, and that entire process up to key publication is end-to-end verifiable. Then your users, whatever your data sources are, would publish commitments to their inputs to that, encrypted to that public key. That whole process is verifiable as well. And then your program runs in a verifiable compute provider. So you have your fully homomorphic program logic running in this verifiable environment. That's going to consume your published inputs, produce an output ciphertext, publish a commitment to that, and then that output ciphertext being published will trigger again this committee of node operators to coordinate to decrypt the output ciphertext and publish your plain text output. And then that entire process end to end is also verifiable. Each individual stage is independently verifiable, and then the aggregate becomes end to end verifiable. And so, yeah, from a developer's point of view or a user's point of view, you have a variety of different entry points along the way where you can interact with, kind of kick off a job, publish inputs, consume outputs, or otherwise just kind of verify that the job is kind of progressing as intended, and that the outputs are what they claim to be. The analog and kind of the reason for the E3 name is a bit of a play on trusted execution environments, TEEs. So these are EEEs. But yeah, the idea here is, again, having this encapsulated, short-running job where you can request a specific program run on a specific set of inputs and then receive an output. And then once the output is published and the committee's job is over, that committee disbands, discards all of their key material, and any future jobs need to kind of reconvene a new committee, use a new key. And this kind of isolates some of the risk in key management and keeps it scoped to each specific job.
All right, that's great. Well, personally, I think the concept is quite interesting. I feel like the concept is quite amazing, but and the name is just gives this very nice feel, like E3, not E4 though. No, E4 sounds a bit too much, right? But
It does
E3 is
roll off the
nice.
tongue as well. Yeah.
Yeah, exactly. Now, I think so the next question, one of the biggest challenges in privacy systems right now is balancing secrecy with trust. And people want their data hidden, but they also want to prove that computation were performed correctly, right? So how exactly does the Interfold keep data private throughout computation while still making results available and verifiable, right? I know FHA it's for computing privately, right? And zero knowledge is so how exactly and why isn't a single cryptographic primitive enough? Like why the need for ZK, for FHE, for threshold cryptography, and let's hear from you.
Yeah. So these are all essentially complementary technologies that give us different affordances. ZK allows us to prove things about data that we know. And so as, say, an individual who's contributing some information to a program, say in an auction program, I'm contributing my bid. Right? So I know what my bid is and I can prove something about my bid. In this case, what I'm going to be doing is encrypting my bid using a fully homomorphic encryption scheme. I'm going to be encrypting it to the public key that was produced and published by the committee for this particular job. And so what I'm going to be proving is that my bid is within whatever bounds is set for this auction. It's higher than whatever the reserve price is, and it's equal to or lower than how much money I have to bid with. And then I'm going to be proving that I know my bid, that my bid is correctly formatted, that it is encrypted to the specific key that was published by the committee, and then publishing a commitment to my bid along with the proof to the chain so that it can then be used in a compute job later. So ZK here is for proving all of the things that I know about my bid, such that everyone else can trust that the ciphertext that I publish is valid for this.
Yeah.
Fully homomorphic encryption here is used so that I can publish my bid, you can publish your bid, everyone else can publish their bids, and then the ciphertext that we all produce are compatible and can be computed over such that we produce an output ciphertext that when we decrypt it, it gives us the result of the auction. And so being able to compute over encrypted data is what we get out of fully homomorphic encryption. And then threshold cryptography allows us to distribute trust in the decryption keys across a committee of node operators such that we don't have a single point of trust, right? We have essentially of-n guarantees. You need some minimum number of nodes in order to be able to decrypt any data from within this encrypted execution environment. And then the last part that's kind of laid on top of this as well is a
Yeah.
system of economic incentives and punishments, such that the node operators they're financially incentivized to act honestly and only decrypt the output of the compute job rather than any of the inputs or intermediate states. If they decrypt the output, they get a reward. If they attempt to decrypt any of the other things, then they have a system of slashing conditions where nodes are essentially incentivized to snitch on one another, to slash one another. So there's this combination of economic rewards and incentives along with ZK, FHE, and threshold cryptography allows us to create this system of, again, encrypted execution environments that give us this kind of unique set of affordances.
All right, that's okay. And this literally just led me to another question, which I think is very important. Now, how exactly does the Interfold handle trust minimization? Because I feel like this would literally go into that. So please.
Yeah, absolutely. So, I mean, in part, we inherit some of this from the blockchains that we deploy the Interfold on top of. We inherit things like censorship resistance and part of the execution guarantees from building on top of a blockchain and having our data structures, or at least part of the data structures, living on chain. We then have verifiability guaranteed by the kind of ZK pipeline. So the entire process is publicly verifiable. And then in terms of correct execution guarantees, we're inheriting that from the combination of the blockchain that we're deployed on, as well as the ZK proving pipeline that runs through the entire compute job. And then guarantees of privacy are based around the threshold cryptography component combined with the system of economic incentives and penalties. So you have this cryptographic guarantees of correct execution, and then economic guarantees of privacy.
All right, that's interesting. So you inherit all the properties, all the most important properties from the chains that you are integrating on, right? All right, that's great.
Yeah, I mean, so in terms of computational integrity, yes, we inherit that from the chain that we're deployed on top of, as well as the ZK stack that we have built our entire pipeline on.
Yeah, that's great. And you also said something about node slashing, and I think I saw something about cipher nodes exactly. So what exactly are cipher nodes, and what role do they play in enforcing the whole security and privacy and correctness across the whole network? What exactly are they?
Yeah, so cipher nodes are the nodes that give us our privacy guarantees in an encrypted execution environment. So we have a pool of nodes that are staked and available to be selected for any given committee. Whenever you make a request for a compute job, a sortition process randomly selects nodes from the available nodes to produce a committee. That committee then needs to coordinate to generate a shared public key that is whatever minimum threshold number of nodes needed to decrypt information encrypted to that public key. So say it might be 10 out of 20 nodes are required in order to decrypt anything that's encrypted to that public key. They publish that public key. Inputs are then encrypted to that key. Compute job runs, produces an output, and then you need 10 of those 20 nodes to coordinate to decrypt the output. They have a system of economic incentives layered here such that if they successfully decrypt the output, then they all get a reward. And if they don't successfully decrypt the output, they all get a punishment. If individuals attempt to cheat and try to decrypt anything else, the inputs, the intermediate states, anything like this, then say you and I are node operators, and I attempt to coordinate with you to decrypt one of the inputs. I pass you my decryption share to try to coordinate around decrypting that input. Then you can take my decryption share and use that evidence to slash my node and take some of my stake. So we have this kind of coordination dilemma there if we want to try to do anything malicious.
That's interesting. Yeah, more like validators but on the network, right?
Right, yeah, very similar to other kind of validating networks, staking networks, where you have a system of a series of actions that are allowed and encouraged and rewarded, and then a series of actions that are explicitly disallowed and have slashing or penalties associated with those things happening kind of verifiably.
Yeah, that's great. Now, this would lead me now to a very important question. So far, I think I've heard a lot, and I think you said something about encrypting for auctions and stuff like that, the use cases, right? So, what exactly are the real world use cases? I know you've said stuff like auctions and voting and other stuff, but are there other like use cases to Interfold? And what kind of teams or projects are already building with the technology, right? And what's your
Mhm.
primary audience? Developers, protocols, or enterprise?
Yeah, so the types of use cases that we're initially targeting are around voting and auctions, obviously. Sealed bid auctions and secret ballot voting. We see these as really critical building blocks to a whole bunch of different problems, particularly in the Web3 space, but also much more broadly.
Yeah,
They are both just kind of ubiquitous mechanisms in all kinds of different system designs. In voting is everywhere from Girl Scout troops to nation state scale governance and everything in between. Auctions are everywhere from real estate to ad tech to how you buy an ENS name and everywhere in between. And so there are these kind of ubiquitous, really critical mechanisms. Beyond that, we're exploring a whole bunch of other potential use cases as well, things like private data analytics, where you're wanting to get information from a whole bunch of different users to produce an aggregate insight, but not wanting to see the individual user's data. We've been working with the Session Messenger on a pilot of this, looking at things like private risk and credit scoring between otherwise competitive institutions. Excited to explore things in the medical space, where you might want to do aggregations of patient data between multiple medical institutions that otherwise could not share data. There's some really interesting kind of mapping problems. There's this credit debt kind of mutual offset space of problems. And then there's obviously a whole bunch of AI related problem spaces, things like distributed or collaborative tuning, training, or kind of co-inference, where you may want to have many private inputs from many different parties.
yeah,
Say in a tuning case, you want to produce your aggregate weights without revealing your individual weights to one another. And so having something like the Interfold enables these kind of use cases as well. So yeah, a variety of different use cases that we're very keen to explore, but voting and auctions are the two kind of beachheads that we know really well, that we know are kind of compatible with the protocol in its current stage,
yeah.
and that we're initially targeting.
Yeah, I think while I was doing my research on it, I realized that those were more of the most compatible use cases right now, currently. But I believe that there are more use cases at the end of the day, right? So that's great, actually. Pretty, really great. Now, I know you've answered this already before, but I think I would just want you to make it like a headline topic right now. So many people are actually familiar with traditional cloud computing and trusted execution environments now, right? But how does the Interfold differ from those approaches when it comes to handling sensitive data and computation?
Um, yeah, so I think like the critical difference is just whether or not data is decrypted, and particularly the kind of inputs or sensitive data from an end user, whether or not they have to decrypt and share that plain text data with another party. Most cloud computing scenarios, you're essentially just trusting your data entirely with whoever the cloud provider is. And so they end up building these huge data lakes that are a massive liability if they're compromised, actively exploited by whoever has access to that data, for essentially ad tech and AI training and tuning at this point, right? You hoard a huge amount of data and you exploit it in whatever way you can. And so I think what's fundamentally different about something like the Interfold is that you can produce the kind of insights that you would like without ever having to take custody of a large chunk of third-party data. So I guess maybe there's two classes of use case that we generally kind of bucket things into. One is where what you gain from something like the Interfold is better integrity guarantees for your system. I think this is where this voting and auction-based use cases fall into. Is by guaranteeing that the inputs are private and remain private, you get better outcomes out of your system. You can avoid scenarios where inputs are tampered with, coerced or colluded, or otherwise kind of exploited against to manipulate the outcomes of the system. And then the other broad bucket of use cases are this kind of access and liability based use cases where by guaranteeing that you never have to see any of the input data, you don't have to take custody of the input data, you either are able to get better access to data, right? You're able to access data that otherwise would be stuck behind some, that some third party would be unwilling to release for whatever reason, or that you would be unable to get access to because of some regulatory burden or whatever it is. Or you are able to get the insight you want without having to take on the liability of taking custody of people's data and having the corresponding risk of it being compromised and leaked. And so these are kind of two broad buckets of use cases, is systems where you get integrity guarantees out of the as an inherited property from guaranteeing that inputs remain private, and systems where you get this kind of access or this access or liability-based guarantees around input privacy being guaranteed.
All right, that's great. Right, I think I do get the whole idea, and it's amazing. While you were talking about this right now, something popped up on my head. So a couple of weeks, a couple of months ago, Google came out to say, oh, they are developing the old quantum machines and stuff like that. So now the question now is that how exactly does the Interfold plan to safeguard its users or its enterprise, the persons that are working on them? What is the plan against quantum machines and quantum threats and stuff like that?
Yeah, so I guess luckily we are post-quantum out of the box, at least for the encryption side of things. We're based on, we're using lattice-based encryption, BFE encryption scheme, later the TFHE and CKS encryption scheme, but these are all based on, this is all lattice-based cryptography that is, again, post-quantum secure already. Some of the proving infrastructure that we're working with is not post-quantum secure yet. This is not a huge concern for us because execution environments are ephemeral and they essentially cease being relevant after they expire. And so a post-quantum attack vector there would not break anything historically, which is the major concern for post-quantum in the context of other blockchains where you have kind of historical balances that will become vulnerable at some point, or for data storage scenarios where you have a whole bunch of data that's been warehoused over time that will become vulnerable as post-quantum attacks become real. And so, in our case, we don't have any, we're not exposed to either of those issues. We have time to update the proving stack as post-quantum threats become more actively real, and in the meantime can benefit from the more succinct classic TK stacks.
All right, that's great, really great. I think this just made me feel much safer. Honestly, I think I feel a little more happy and safer, right? So, and before we wrap up right now, I'd love us to look into the future, I'd love us to look ahead. Let us look ahead, and I want to talk about the milestones that we've reached at the Interfold, and then what exactly is the plan for the future? Like, what should the community, developers, and privacy enthusiasts be paying attention to over the next 6 months, and what exactly is on the roadmap right now? So that's the whole idea. I don't know.
Yeah, for sure. So to date, entire challenge has been kind of the research and engineering effort to get the Interfold to a point where it can be production ready. We are days away from that, so it's very, very close, and we're really, really excited to start pushing this thing out into production. The kind of upcoming things that folks should be looking forward to and paying attention to, we will have a public testnet here very shortly. I'm not sure how fast you publish. It may be by the time that this is published, we've got a more public testnet up and running that folks can come and run a node on and start building some programs against. We are hoping to have a public launch of this towards the end of this quarter or very early next quarter. So very, very soon this thing will go much more live. And then in the I guess weeks and months after launch, looking to just continue pushing things forward. We have a version of our publicly verifiable DKG and decryption algorithms running, but we're making some significant optimizations for that now. So I think the big thing that we'll see is a push from relatively small committee sizes, in the 10 to 20 node range, and start pushing that out to much larger committee sizes, kind of into the low hundreds and eventually much, much higher than that. And then the addition of additional encryption schemes. So currently we're supporting the BFV encryption scheme. This is a kind of precise FHE scheme that generally has limited kind of multiplicative depth, so it means relatively simple programs. But we'll push into adding additional encryption schemes, so TFHE and CKKS are the other two that are high priority.
Yeah.
And that'll radically change the design space on the type of applications that we can build on top of it and the type of applications that others can build on top of it. And so, yeah, ultimately what we're hoping to do here is build out an ecosystem of developers and applications building on top of the Interfold. Help support those applications, support those builders as much as we can, and really start to explore the design space here. We can only push forward so many verticals in parallel, so we need this ecosystem of people building out applications on top of it, and kind of inheriting this set of guarantees that we've enabled with the Interfold as a protocol.
That's great. I know that was supposed to be the last question, but since you said something about support, I wanted to ask, like, who are the persons backing the Interfold? And then I think I heard something about a token and stuff like that. So what's the future? What's the plan? First of all, who are the partners and the persons, the projects backing Interfold, and then the future token that's coming up?
Yeah, so well, we can talk about token quickly. So this is obviously a critical component to the protocol economics. We talked about slashing and reward conditions.
Yeah.
And so, yeah, the token is a critical component to the mechanism that is the Interfold. It's the native token for the protocol. It's what node operators will stake in order to run a node. It's what they then are putting at risk in the case of misbehavior. It's also part of what they're rewarded with when they honestly run their nodes. And so, yeah, this will be part of the public launch, will be a kind of broader distribution of the token. The partners that we're working with, we have a variety of them. I guess critically, some of the partners that are kind of building immediately that we're working with right now, folks like Aragon and the Aragon Foundation. We have an integration there that they're really excited about. This will bake the Interfold's voting solution into Aragon, so any organizations using Aragon can choose to enable private voting on their organization. This will be a really big step forward there. We're also working with the Session Messenger application on some private data analytics use cases, exploring private auction use cases with MetalX and a handful of other organizations, and then have partners in RISC-0 for our ZK proving pipeline for part of it in the compute provider, and a handful of others that I'm missing off the top of my head now. But yeah, Truo actually is another one. So Truo is a prediction market. We've just started working with them on some really interesting designs around their Oracle mechanism. I think they're going to have a best-in-class Oracle resolution mechanism, and a large part of it is private voting. We're kind of early on in that discussion and kind of figuring out whether the Interfold is the right solution for them, but it feels like a really good fit.
That's quite amazing. I really look forward to seeing more partners and more teams joining the Interfold pretty soon, right? So I think that's all for today. Thank you so much, Auryn, and I'm sure you that this has been a very lovely session from you. It has been super, super amazing for real. Yeah.
Yeah, thanks. I appreciate you having me. It was lovely to chat and great to meet you.